So now we will start the non-uniform circular motion. Non-uniform circular motion. Non-uniform circular motion. What is the non-uniform circular motion? Tell me. If the velocity, the speed of the particle, this is the v1, right? This is the v2, and this is the v3, like this. So the magnitude of the velocity is changing continuously together with direction. Is it clear or not? This is the non-uniform. If speed of particle is changing with time, all right. If the speed of the particle is changing with time, then non-uniform, it is called non-uniform circular motion, right? So it will have the two types of acceleration, है ना? It has two types acceleration. What are those? First, the tangential acceleration. The AT, which is nothing but dv upon dt, which is responsible for changing the speed. And listen one thing, which is responsible for changing the speed. Is it clear or not? This is the first acceleration. And the second acceleration is what? This is centripetal acceleration. The AC is equal to dv. AC is the v square upon r or r omega square. This is the AT, this is the AC. And this acceleration is responsible for changing the direction. Responsible for changing the direction. Is it clear or not? Please copy this first. So this is the non-uniform circular motion where the tangential and centripetal acceleration will be over there. It is responsible for changing speed. It is responsible for changing velocity. Listen one thing. In the rough, you can write if the particle is moving with velocity v and the acceleration is a, so then the velocity will be increasing. Or you can say if the velocity is increasing, so the acceleration must be in the same direction as that of v. But if this is the velocity direction and it is continuously decreasing, so the acceleration should be opposite to the velocity vector. Is it clear or not? So in this case, in the non-uniform circular motion, there may be the two cases when the speed is continuously increasing or the speed may decreasing. All right. When you switch on the fan, the speed of the particle on the blade of the fan is continuously increasing. In this case, right, you can write this the case 1. If v is increasing, what does it mean? It means, for example, at t is equal to 0, it start the motion from here, and after some time the velocity become v and it is continuously increasing, suppose, right? So at this time, due to changing the direction, the centripetal acceleration will be in this direction and the tangential acceleration will be in the same direction as that of v. Do you understand or not? Right? So okay, so what will be the resultant acceleration? This is the resultant acceleration. So the resultant acceleration vector is AC vector plus AT vector. If you take the magnitude, then this is AC square plus AT square. The AC is nothing but V square upon R, right? And the AT is nothing but dV upon dt. Is it clear or not? So this is the resultant of the magnitude of the acceleration. In this case, the resultant acceleration, the velocity, this is the angle theta. The theta is acute angle. This is asked many times between resultant vector and velocity vector. Is it clear or not? That is the thing. Also, if the velocity or the speed is decreasing, So what will happen? Suppose the fan is running on, and when you switch off the fan, so the speed of the particle on the circumference of the blade of the fan will reduce slowly. Suppose this is the velocity vector, right? And speed is reducing. So what will be the direction of the acceleration? The tangential acceleration will be opposite to that. But because of the circular motion it is performing, the radial acceleration or centripetal acceleration, whatever you call this, radial or centripetal acceleration will be in the same direction. So this time it will be the resultant acceleration. Are you getting or not? So what is the here the angle between v vector and at vector? The angle is 0. Here the angle between v vector and at vector is 180 degree, and the angle between the resultant vector and the velocity vector, right, will be alpha, which is this is suppose the theta, which is obtuse angle. In this case the resultant vector will be same as ar plus at, and the same magnitude you will write root over v square by r whole square dv upon dt. Is it clear or not? But the angle theta is obtuse angle between the velocity vector and the resultant acceleration of the particle of the mass m. Is it clear or not? Listen, one more thing. If somebody asks, if there is a non-uniform circular motion, how many acceleration or how many forces are active on this? Only this is the resultant acceleration, and the net force will be, if somebody asks what is the net force, so if this is the mass m, the net force will be in the direction of this only, right? So what is the net force? Say m into resultant acceleration, right? In the same way it will be the net force in the same direction, no doubt. One more thing, this is the centripetal force and this is the tangential force will be there, right? So resultant and tangential force are not the separate force here but applying by the ground, rather the net force is this, and these two are the component, the horizontal and vertical component. Are you getting or not? So that is the thing. Please copy this. Suppose this is the example in which a particle performing a circular motion and whose centripetal acceleration is given in the question, and this is k square rt square, right? So centripetal acceleration is not constant first of all. In uniform circular motion, UCM, the v fixed and the radius is fixed. So what is the centripetal acceleration? Is equal to v square upon r. It is constant or not? So it is the uniform circular motion. When the centripetal acceleration is changing with time, so it means it is not uniform circular motion. So AC is equal to what? K square r t square, which is equal to v acceleration. Centripetal can be written as v square upon r, k square r into t square. So v square is equal to what? Say k square r square t square. So the speed can be written as k r into t. Is it clear or not? So the speed of the particle is what? Say changing. Suppose at t is equal to 0, what will be the speed? At t is equal to 0, it starts from rest. It is confirmed by this expression, right? So the speed if increasing, send the tangential acceleration, which is nothing but rate of change of speed. So if you differentiate this is the tangential acceleration. Are you getting or not? So that is the thing. So now in the first part, the speed of the particle, any instant of time. What is the first part? The speed is kRt. This is the first part. The second part, tangential acceleration of the particle is nothing but k into r. Do you understand or not? Third, the resultant acceleration, when it reaches at this point, so it will have the tangential acceleration and the centripetal acceleration. So what will be the resultant acceleration? It will be AC square plus AT square, right? So AC, what is the AC? This is the AC. As a function of time t, we have to find this quantity AC is equal to k square r t square ka whole square. And what is the AT? AT is kr ka whole square. If you simplify this, the kr will be common. the kt square का whole square, right, plus 1. So this is kr root over k square t की power 4 plus 1. So this is the resultant acceleration according to the relation. Is it clear or not? And what they are asking in the D part, angle made by the resultant with tangential direction. It means they are asking this angle alpha or whatever you want to write theta, because this is the tangential direction of the velocity, this is the resultant. So how to find the angle theta? This is the tan theta, is nothing but this is the AC and this is the AT. Is it clear or not? So tan theta is nothing but AC upon AT. What is the AC? This is the k square RT square divided by AT. This is k into r. So kt square, this is the tan theta. So the angle is nothing but tan inverse kt square. So this is our fourth part of this question. Do you understand the solution? Yes, please copy this. Now you have to find tangential and the total acceleration. Okay, so this is the question. If a particle, you can assume, is moving the radius of the 2 centimeter, and suppose at t is equal to 0, the particle velocity is given according to the question 40. Is it clear or not? Now, what is the speed at initial? When t is equal to 0, the speed is this. So the speed is a function of time t and it is continuously increasing. Is it clear? From this, the tangential acceleration dv upon dt you will find, which is equal to 4 meter per second square. So this is the tangential acceleration. It may be the constant or it may be the variable, but here the tangential acceleration is 4 meter per second square. What does it mean? It means the speed of the particle is changing by 4 meter per second in 1 second. Is it clear? What is the meaning of the acceleration mean? 4 meter per second square mean the speed of the particle is changing by 4 meter per second in 1 second. That is the meaning of the AT. And after some time, suppose at t is equal to 1 second, they are asking first of all the tangential acceleration. So the answer of the first part is tangential acceleration is 4 meter per second for all time, right? For 1 second it is. Now in the second part, they are asking the total acceleration. To find the total acceleration, you must know the tangential acceleration, which is constant, right? Which we know. Also, you have to find the centripetal acceleration, or you can say the radial acceleration. The radial acceleration value is v square upon r. The radius is given. Only the thing is that the speed you have to find. At what time the speed you have to find? At 1 second. So at t is equal to 1 second, what is the speed? 4 into 1. 4 meter per second is the speed. So what is the radial acceleration then? The 4 square upon radius. The radius is 2 centimeter. Is it clear? So this is 16 upon 2 into 10 की power minus 2. This is 800 meter per second square. Wait for 1 minute. The speed is given in centimeter per second. All right. So this speed is in 4 centimeter per second. Are you getting or not? Yes. So the tangential acceleration. Right. Also, this acceleration will be found in centimeter per second square. In centimeter per second. Please make it correct. Centimeter per second square. So V is what? Centimeter per second square. So the speed is 4 square. The radius I will write in the centimeter only. So this is the 8 centimeter per second square is the radial acceleration. Is it clear or not? But the total acceleration we have to find. The resultant acceleration is nothing but root over AR square plus AT square. So what is the radial acceleration? It is 8 square. And what is the tangential acceleration? Is 4 centimeters square. Now when you will calculate, this is 64, 16. So root 80 centimeter per second square will be the correct answer. This is the resultant acceleration in this case. Are you getting or not? Hmm. Yes, yes. Listen one thing. According to question, a particle of mass m is moving on a circular path and the radius is capital R, whose velocity depends upon the distance covered by this. For example, at t is equal to 0, particle start from here, and then after traveling the distance s on the circular path, right, its speed become v, and the v is root alpha. It is the misprint in the book. This is the alpha root x. This is the speed. Is it clear or not? So you have to find, after traveling the distance x, you have to find the acceleration. The acceleration means the total acceleration. So it will have the radial as well as the tangential acceleration, and the resultant acceleration you have to find. Is it clear or not? So the speed after the resultant acceleration should be in terms of s, because this is given in the question only, right? So the speed is very much clear, it is given. So the radial acceleration or centripetal acceleration v square upon r you can write. So this is alpha root x upon r. So this is s alpha square upon r. So this is the radial acceleration. How to find the tangential acceleration? It is dv upon dt. But since the velocity is given in the displacement s, so the acceleration will be written as v dv upon ds. You understand this acceleration formula? Please tell. Very good. So the v is in terms of x as it is, and you have to differentiate this alpha root x once again with respect to s. Y is equal to root x. What is the differentiation of this? Root x differentiation. Yes, tell me. The answer is 2 root x. You have to remember directly for your easy calculation. How does it come? I will explain. This is the dy upon dx is equal to n x ki power n minus 1. 1 by 2 x ki power minus 1 by 2 upon x ki power 1 by 2 upon 2 root x. Is it clear or not? What you have to remember? What is the differentiation of root x? Say 1 upon 2 root x. How does it come? I explain. You understand this solution? Right. So now we come to return back to this. So this is the v and this is the dy dx of alpha root x. Alpha is constant, right? So it become alpha square into root x. And what is the differentiation of root x? Say 1 upon 2 root s. Is it clear or not? And it become alpha square by 2. So the tangential acceleration comes to be alpha square by 2. Now the resultant acceleration is AC square plus AT square. The AC is S alpha square by R whole square. The tangential acceleration is alpha square by 2 whole square. So what is the answer? The alpha square will common, s square by r square plus 1 by 4. This is the resultant acceleration of this question. Understood or not? You tell. Okay. So I will give you 1 minute to think about this. But before this, I will explain you some concept. What is the concept? The relation between tangential acceleration and angular acceleration. As I have given you the relation, suppose this is the speed v, the angular velocity is e r. So v is equal to r omega, in the magnitude it is, and in vector form v is equal to omega cross r, right? I had explained. Is it clear or not? If the velocity is constant, then this happen. Are you getting? For example, the running fan. After a long time, the fan runs with the constant angular velocity continuously. Are you getting or not? But if the fan is at rest, if the fan, this is the fan suppose, and it is at rest, right, like this is the fan, it start rotating. If you consider the any particle which is performing the circular motion, so its velocity is continuously increasing, so its angular velocity is also continuously increasing, so it will have the tangential acceleration, also it will have the angular acceleration. Are you getting or not? If sometime the velocity is v, the radius is r vector, so angular velocity and the linear velocities are related like this. How the tangential acceleration and the angular acceleration are related? You have to differentiate with respect to t again. Are you getting or not? If you differentiate this expression with respect to t, dv upon dt is the rate change of the speed, right? So which is at and this is r. D omega dt is nothing but the angular acceleration alpha, right? So this is the again the relation magnitude between at and r alpha. If you write the vector form, the tangential acceleration is alpha cross r, right? Where alpha is what? Say angular acceleration. Although we will discuss in more detail in the rotational motion this expression, right? But here just only the tangential acceleration, if it is the tangential acceleration, this is the angular velocity, direction is omega, like this. So angular acceleration will be in the same direction. This is the one thing. You understand this concept or not, you tell? Right. Listen, one more thing. As I told you, suppose this is the rough horizontal plane, right? Rough horizontal plane, and a car is moving like this, right? So it required the friction or not? Without friction it cannot move, and the friction between the tire and the rod is the static friction, whose range is from mu into n, or the static friction lies between mu mg if it is in the horizontal plane. So what is the maximum friction available? Say mu mg. Friction cannot be more than this. Are you getting or not? Yes, copy this. Now the question number 8, you can think this. Okay, so in the question number 8, what is given? A car is moving, start moving, right, with the constant uniform angular acceleration. If you consider this the horizontal surface, right, the car start from here, suppose, right, this is the car, it is moving. When it reaches to this point, after some time, right, the friction coefficient is, maximum friction coefficient is mu. So what is the maximum friction force available? Say mu mg, because this is the mg and this is the normal. Listen, one more thing. It is not the uniform circular motion. In uniform circular motion, only the centripetal force or the friction force will be acting in this direction in the uniform circular motion. Is it clear or not? But when the particle or the car is moving with increasing speed, suppose its speed is increasing. So if its speed is increasing, why the speed is increasing? Because it has the angular acceleration. So what will be the tangential acceleration? Say r into alpha. Is it clear or not? So this tangential acceleration mean the this angular acceleration, due to this rate of change of angular velocity, the speed is also increasing. What is the speed? Say r into omega. What is the tangential acceleration? Say at is equal to r into alpha. Or listen, one more thing, the centripetal acceleration will be this. Is it clear or not? You tell. So if this the tangential acceleration is equal to r into alpha, this angular acceleration in this question is constant. So the tangential acceleration will also be constant. So the dv upon dt is equal to what? Say r into alpha. So what is the velocity after time t, you have to integrate r alpha into t from 0 to t at t 0 to v, right? This is the limit. So v is equal to r alpha t will only come. Is it clear or not? So at this time, the speed we know, which is equal to r alpha t. So the centripetal acceleration can be written easily. What is the centripetal acceleration? Say v square upon r. This is the L alpha r alpha t whole square upon r. Centripetal acceleration is r alpha square t square. Is it clear or not? You tell. Right. The tangent angular acceleration is given, and with the help of this, the tangential acceleration is found. So tangential acceleration is nothing but r alpha dv upon dt, and the velocity can be found. If you know the velocity at any time, the centripetal acceleration can be written easily. Is it clear or not? So this is the centripetal acceleration, tangential acceleration. What will be the resultant acceleration then? The resultant acceleration will be root over AC square plus AT square. The AC is nothing but r square alpha square t square whole square, and the tangential acceleration is r into alpha whole square. So r alpha will come out from the integration alpha t square plus 1. Is it clear or not? That is the thing. This is the resultant acceleration. Listen one thing. As the time is increasing, the resultant acceleration is increasing. What is the maximum resultant acceleration available over there for the car without skidding? What is the maximum tangential acceleration? You tell. The maximum tangential, this is the maximum force, the maximum resultant acceleration, this is the maximum friction force available. So what is the maximum resultant acceleration? Will be equal to Fs max divided by m. So mu mg upon m. So the maximum acceleration is mu g. You have to remember. You understand or not? What is the max? Yeah, what may be the maximum resultant acceleration? The maximum resultant acceleration may be the mu g. As the time is increasing, the resultant acceleration is increasing. This is the maximum value. So after this, the car will skid. So you have to find the time in the part 1, so that block and turntable, right? You may consider this the turntable. Sorry, for the question, this is the table you can consider, or you can consider the horizontal circular motion on the rough circular track, right? So this is the mu g is equal to r alpha. So this is what? Say alpha t square plus 1. Is it clear or not? So now from this expression you can find the value of t. How to find the value of t? Square root both side, r square alpha square t की power 4 it is, plus 1. Is it clear? Mu square g square upon r square alpha square is equal to alpha square t की power 4 plus 1. So alpha square t की power 4 mu square g square, right? Wait for 1 minute. Mu square g square upon r square alpha square minus 1. So t की power 4 is mu square g square r square alpha की power 4 minus 1 upon alpha square. Is it fine? Then the t is equal to mu square g square r square alpha की power 4 minus 1 upon alpha square की power 1 by 4. So this is the time after which the car will skid on the circular track, or in this question the table is given, and the block is at rest. The same explanation will be done for the both cases, right? The same thing. When it will start turning, when it will start rotating, So the resultant acceleration will be increasing continuously. So the same solution will be work for this, right? Of the particle. Okay, wait for one. I will try to understand. A particle it move like this, right? And once in figure 1 and once in anti-clockwise sense, again in clockwise sense. First it is going like this, then it is stop over here, and I think it move in the same direction. Are you getting or not? So what is they are asking the average angular velocity. Average angular velocity is nothing but total angular displacement divided by total time. Are you getting or not? So what is the total angular displacement in this case? You tell. The initial angular displacement is 2 pi in this direction, and then it move in this direction. Are you getting or not? So the initial angular displacement, if you take, this is the positive side, so theta 1 is plus 2 pi. Are you getting? And the angular displacement is in this direction, so theta 2 is minus 2 pi. You understand this thing or not? Tell me. So theta 2 is minus 2 pi, it is minus 2 pi, and the total time is 2 seconds. So if you take the magnitude, the 2 pi radian per second is the angular velocity. It should be the answer. To each. So then the 4 divided by 4, right? Because total time is 2 plus 2 is equal to 4. Then the pi radian per second is the answer. Is it clear? This is the average angular velocity. All right. Any other doubt? Listen. T2 minus T1 is nothing but the time interval between the initial start it motion. It start from here, so T1 is 0, and then when it come, so when it reaches to the same position, it become 4 seconds, right? So T2 minus T1 is nothing but the time difference or time interval between initial and the final position.